Boy, we're in the home stretch now. We're finishing off chapter 7 about radicals. Good job if you're keeping up with this and watching videos and getting all that homework done and attending the class or at least watching the Zoom videos. Good job. I hope it's going really well for you. Okay. This section I'm going to do in one lesson as well because there's not too many examples here. When I got into building it, I just went like, it's pretty much the same process over and over and over again. So basically, it goes like, we're going to solve equations that have got square roots or cube roots or whatever in them. So I have here for you guys to just kind of watch a progression. It's kind of interesting. Okay, I say solve the square root of x is 5. Okay, so the question is, what goes here in order to get 5? And what we know is, well, the square root of 25 is equal to 5, right? And that's what's happening here. So we just realized, oh, okay, yeah. But you don't want to think too... Watch this next one before I start saying that. Okay, solve the square root of this expression is equal to 5. Using the same logic, it must be that whatever this is, right, whatever's under here, when I square root it to get 5, this thing must be 25. So this thing must be, I think I have a typo. It is a typo. This has got to be 25. Oops. Okay, so we solve this equation to find, and I don't have the right answer now. It is 27. Oh, the answer is actually 9. Interesting. So let's see. 9. I'm going to check because I have a typo. 9 times, that's 27 minus 2. Okay, let me show you that progression. Whenever you want to check, and that's important in this section, we say x is equal to 9, not 7 over 3. I don't know. I was tripping. Okay, when I put in 9, I get the square root right here of 3 times 9 minus 2 is equal to the square root of 27 minus 2 is equal to the square root, there you go, 25, of course, and therefore the square root of 25 is 5, and it checks out. Well, what's the story? What's the story? I mean, we don't usually do it that way. Let me look at this a different way. If I had this problem, the square root of 3x minus 5 is equal to 5, right? The mechanics are, you don't have to think like, oh, that's got to be 25. Instead, what you do is you square both sides. And that releases, square root and square cancel. It releases these guys out from under the house, and off you go to the races. You want to try it? Okay. Here's a couple problems to try. You can pause, and I'll get back to you. Okay. This one, I hung you out to dry. You can't square both sides until you get rid of the 2. So that's your first move. Get rid of that 2. Oh, well, you should have said that. I know. I'm sorry. So I got 5x plus 4 is actually equal to 5 again. Okay. What do? How do we get rid of the square root? See, that's how you start thinking. Instead of going, well, that thing has to be 25, I think. Instead of that, which is good, instead we just go, I'm going to get rid of the square root by squaring. And I'm going to get rid of cube roots by cubing. You're going to see that too. So our problem becomes, now watch out. They break apart, they release the 5x plus 4 from their prison, but over here the price is you got to square that side. And the rest of the way we're solving. La la la, 5x is equal to 21. Divide by 5. You may not like the look of the answer, but that's a true answer. It's 21 divided by 5. Okay? Think about plugging that in. 21 divided by 5. It works. Now let's go to the next one. Now this one's got a square in it. It's kind of hard to figure. It's not really easy to figure out what the answer is. That's not what we do. We just simply go, okay, you give me this and you're telling me to solve? All right. You know what I'm going to do? Can you guess what I'm going to do? You know how I'm going to get rid of that radical? That's right. Not, oh, that's a 2. So I'm so mesmerized by 5. It's a 2. What am I doing? Okay, square. Must be losing my mind here. That cancels, doesn't it? Really? You are released from prison. X squared minus 3x is now equal to 4. Don't forget to square both sides. Otherwise, you just imbalance the whole equation. Now look what we're left with. It's a quadratic equation. What do we do with that? What's that stand for? Oh yeah, get 0 on one side. Factor the other side. And then set each factor equal to 0 and solve. Okay. Now you got to watch out for these problems because the square root is the principal or primary root. When you square root numbers, you get a positive. Even though there's 2 possible roots, there's like for instance, the square root of 4, we call it 2. But you know what? That's because 2 squared is equal to 4. But that's kind of not right because minus 2 squared is equal to 4. How can we choose the positive root instead of the negative? We just do. So that messes our equation up a little. So actually, we should check. We should check. And that's a thing that you have to learn to do with roots and radicals, just like you did with rational equations in the previous chapter. When you clear the fractions, you got to watch out. Don't divide by 0. In this case, it may not work. Let's find out. So I'm going to check by plugging into the original equation. X squared minus 3x. When I square root that, I should get 2. Our first check is the number 4. And you don't have to spend a lot of time on it. You just got to be deliberate. You go, that's 16 minus 12. Okay, that's the square root of 4. Yep, that's 2. That one works. Isn't that neat? Over here, square root of x squared minus 3 times x should get 2. Let's see if this one works. If it does, it does. If it doesn't, it doesn't. Minus 1, minus 1. We're checking those guys. So when we square minus 1, we get 1, don't we? So under the radical, we've got 1. Look at the double negative. Plus 3 is square root of 4. Yep, that's equal to 2 as well. It's good. So both answers are good, but sometimes you lose an answer because it doesn't work. I don't know if I have an example of that, but okay, let's keep going. All right, so that's the essence of it. We're going to isolate a radical. This next problem, a couple of problems, okay. I'm just going to say go for it. The one here, watch out, has got a cube root. Otherwise, this has got a square root. This first one's not terrible. The second one gets a little dicier. And then the last example is, whoo, you're going to earn your keep on that one. Let's do it. Okay, let's make it routine. The story is 1, isolate whatever radical you're looking at. 2, and I think I wrote this down somewhere. I think it's on a previous page. Power each side. 3, solve. And 4, check. Should check your answer. Not all the time. If you get one number, it's probably going to work, but it's really good for you to check your answers just to make sure and to see that you're not just whistling Dixie here. You're actually finding the answer, and it works. Pretty amazing. Okay, what do we do here first? Let's see. We have 2 times the cube root of x plus 4 minus 3 is 5. Oh, boy. Well, we're going to get it to where we are going to isolate this radical. Okay. What do we have to do that? Well, how about first we add 3, right? So we have 2 cube root of x plus 4. Over here, what do we have? 8. What's next? Now let's divide the 2 out. Okay, I'm getting it ready to go. And so on this side we have 4. Okay, great. So now what? Well, now we're going to power each side, but I have a question for you. Which power? Which power should we use here? Did you fall asleep on me? See how it's a third root? We should, watch out, wait for it, cube each side. cube each side. Why? Because the cube root and the power 3 cancel, and we're released. On the other side is whatever. In this case, it's 64. Subtract it over, x is 60. And that's the answer. Should I check it? Should I check it? It's an easy check. If you put 60 here, you get 64. Watch out. You cube root 64, I'm going to tell you, you get 4. 2 times 4 is 8. 8 minus 3 is 5. That one I kind of figured is going to be okay, but this next one should be interesting also. 2 more examples. Hang in there. The story is, as always, isolate, power, solve. Here we go. First move on this one should be add the 6. Get them over there. But look at what happens on the right-hand side. Uh-oh. We have the square root of 1 minus 8x is equal to, no other way to say it, but x plus 6. Big deal. That's what we got. These are good problems. I like these problems. They make us think. Ready? Okay, what are we going to do next? You know what? Yeah. We're going to do what? How do we get rid of the square root this time? Square. How do we get rid of the cube root? Cube. How do we get rid of the 5th root? 5th power. You got it. Now watch out on the other side. Some people, it's too much math and they make mistakes here. Don't let it be you. Hang in there. Practice. Wrap this and square it. Just write it down. I'm going to square this. Okay. What's supposed to happen in math if you're really revving is, first of all, boom, that's why we did it. We're free. We're free from prison. But on the other side, people are supposed to look at that and go, wait a second. What do you do with that one? When in doubt, what does Weber say? Write it out. That is a FOIL, friends. A lot of people make that mistake. Don't let it be you. So 1 minus 8x is equal to x times x, x squared, 6x. Here comes another 6x and a 36. What kind of an equation are we looking at here? That's right. Another factory thing, another ZFS. Zero factor and solve. Why? Because it's got a square in it. X squared is sitting there staring us in the face. So 1 minus 8x. I like to clean this side up first. This is actually 12x. Okay, one less term to worry over, right? But we're going to make a 0 on the left, so we're going to go minus 1, plus 8x, plus 8x. This goes away, and you got 0 on the left. I don't care which side it is. And on the right, we have x squared plus, what is that, 20x, and then plus 35. Something went wrong in my problem. I think I have a problem with my problem. Oh, bummer. Okay. What? I thought I had this worked out as 12. Right? I must have copied down the wrong one. I'm going to change the 8 so that it works. Just don't look when I do that, okay? I think what I want is a 12. Oh my gosh, that's terrible. Okay, 5 times 7 is 35. But I already have 12 from the 6. Oh my goodness, glory. Okay, well, this would have to be, okay, so what we would want to do in this case, and the problems will factor in your text. I'm kind of embarrassed. What we would have to do is go to chapter 8 and do what? Quadratic formula. Next chapter. Well, this is an example of how math isn't always clean, and there are mistakes to be made. Okay, one more to show you. Sorry, we'll have to defer that to chapter 8. Gosh, that drives me crazy. So, lastly, here's another problem. And this one is pretty nasty. It's got 2 square roots. Okay, let's see if I can redeem myself with this one. Okay, so again, isolate a radical, square both sides. Except look what happens here. Okay, let me write this out again. I've got the square root of 4x minus 3 is equal to 2 plus square root 2x minus 5. I'm going to square both sides because that'll get that guy free. But the price is to square this side, and that's the challenge. So on the left, I'm free. And on the right, okay. Let's do a table, I think, because I don't want to get lost, believe it or not. Yeah, what we have is 2 plus the square root of 2x minus 5. It has to multiply with itself twice. So I duplicate it because it's being squared. So what do we have? We have 2 and radical 2x minus 5. And 2 and radical 2x minus 5. Okay? Oh boy, watch out now. You ready? Who wants this one? 2 times 2 is 4. 2 times the square root of 2x minus 5. And again, 2 times the square root of 2x minus 5. Well, what happens in the last one? They square. We're going to have square root of 2x minus 5 times the square root of 2x minus 5 is the square root of 2x minus 5, guess what? Squared, what happens? They cancel out, and you've got 2x minus 5. Okay. So we have 4x minus 3. Your eyes are crossing, aren't they? That's right, what we have. We have 4 plus 2 square root 2x minus 5. You have 2 or 3 of these in the homework to do, so we better watch this video. Plus 2 square root 2x minus 5, and then plus 2x minus 5, okay? Woof, don't give up. You have to do it again. When you have, like I said, one of the more challenging equations, I should have said, in the semester is this. Okay, but we can do it. We're almost there. We're like halfway there. So 4x minus 3, what I'm going to do is clean up the the right-hand side, okay? So, for instance, let's see. I'll bring the 2x in front, and I'll put the 4 minus 5 and write down minus 1. And then these two guys, 2 of these square roots plus 2 more, means I've got plus 4 square root of 2x minus 5. Okay? What I'm doing is I'm going to isolate the radical again. I'm going to square, and then I'm going to solve. That's what I'm thinking. So I'm going to isolate. That means I'm going to get minus 2x, plus 1, plus 1. Okay, stop right there. The 4 is attached by multiply. So we have 2x minus 2 is equal to 4 square root 2x minus 5. And it's at this stage you have a choice. You can divide the 4 over and create fractions. If you're not afraid of fractions, great. But if you're like me, I don't want to deal with the fractions, I'm just going to square both sides again. I'm going to square this side, and I'm going to square this side. Okay? Wow, what a problem. I'm telling you what. Okay, so we have 2x minus 2 squared, multiplied with itself, 2x minus 2. On the other side, I have 4 radical 2x minus 5 times itself. On the left is a FOIL, so bear with us. 4x squared minus 4x plus 4. Okay. And then on this side, I've got, well, I want to get rid of 4's, but I'm going to do this. I'm going to go 4 times 4 is 16. And then I have the radical times radical. We did it once before. We're doing it again. 2x minus 5 without the radical. And I think we have another quadratic equation. I've got 4x squared minus 8x plus 4 equals, watch out, 32x minus 80. Isn't that so? I'm going to ZFS. I can hear the weariness in my own voice. It's really bugging me that problem didn't work, but okay. Minus 3, I'll get over it. You too. Minus 32x. Plus 80. What do we get? We get 4x squared minus 40x plus 84 is 0. Okay? Well, you know what I like to do, right? I'm going to divide by 4 to make the numbers smaller, totally legal when you're solving equations, we're getting an x squared minus 10x minus, in this case, 21, or it's plus 21, is 0. Thank goodness it factors, or else I would have started over. So we have x minus 3, x minus 7. We get x is equal to either 3 or 7. And if you go up to the top and you check your answer, I'm not going to do it. I think we're tired. I'll just say they both work. Now that's a doozy, isn't it? Thanks for listening. And now we have an inside joke with each other. Weber did a problem that he couldn't solve. 20-minute video. Oh my goodness. Thanks for bearing with it.